Hi, my name is Sasha Tarasenko, and we're here today to talk about the AP Human Geography models. So, the first model we're here to talk about is the gravity model. So, this talks about the interaction between two cities and how they can be determined by population size and distance. So, this assumes that distances decrease interaction. So, the greater the distance, the less likely we are to interact with it. And population size increases interaction. So the larger a city or a center may be, the more likely we're to interact with it. So let's say we're more likely to go further for a superstore. Let's say we're more likely to go further for Lenox Mall than we are maybe to go for a CVS because there might be one that's closer and there's less likely to be a Lenox Mall somewhere other than Atlanta. So what this doesn't consider, however, is boundaries between cities. So let's say a political boundary. And let's say we're on the US-Mexico border and we are on the US side, but we need to go to a superstore. And the only one that there is one of the closer one is on the Mexican side, but we need one on the US side. So we go to the one that's 20 minutes away on the US side rather than 10 minutes away on the Mexican side. So a related model is the distance decay because this only talks about distance and interaction. And friction of distance talks about why distance hurts interaction, and it's because it takes more time to travel longer distances and it costs more. So it costs more gas or more money and more time. So space-time compression is what happens because of our technology. So because of texting or because of phones, we can text rather than having to mail. And the type of diffusion that's most closely related to this model is contagious diffusion because it talks about how the smaller the distance, the more likely the idea is more likely to spread to that area. So the next model is the DTM, otherwise known as the demographic transition model. So this talks about population and how population relates to the development, and more specifically about the population, the relationship between birth rate and death rate. So this birth rate and death rate can be amounted to the NIR. So this is natural increase rate. So this talks about the amount of births minus the amount of deaths. So you can see here in each stage. So this is the NIR. It increases over time. And in the first stage, you have high birth rates and death rates. So you have a lot of people having a lot of children, but they end up dying. So in stage 2, this is when the death rates start to go down. So the population starts to increase. And in the third stage, the birth rate starts to go down because there's less of a need to have more children. And it's more expensive too. So the population still increases though, because you have more people from the stage 2 giving birth. So in stage 4, even though it's still increasing, we have a decrease in birth rate, and it's becoming such a concern that some countries like Japan or any what is it, like Norway, for example, they try to do population policies where they can try and raise that birth rate. But countries like China, back in the 20th century, they had a negative policy where they tried to limit the amount of births they would give. So in stage 5, these are countries like Japan and Korea who are actually having really high, both lowered birth rates and actually starting to have a really close death rate. So there's very little difference in population. So this related model is population pyramids, and because it's a different way to describe the population and how it develops over these different stages. So you can see this is stage 1, it has a very large base, and as you develop over time, it gets a smaller and smaller base. And one thing that's important about this is the dependency ratio. So you want to make sure you have a very large working population that can support the non-working population. And that becomes a concern in stage 4 and 5 because there's less of a future to support the current working population. And one thing that this model doesn't consider is that people can fall back on that model. So countries like, let's say, China or Russia, they can fall back in their stages of development because of something that economically happens or something that socially happens. And this just assumes that all countries progress in the same way when in reality they don't. So the next theory is the Malthusian theory. So this talks about population and how population growth can be limited by food supply. So this assumes that population growth is geometric, otherwise exponential, and it talks about how food supply is linear, so it can't really support the population at a certain point, which would be right here. But it doesn't consider that population growth can be slowed down, and like in the DTM, it shows that population growth can be slowed by human choice. So the birth rate can be slowed, which means the population growth can be slowed. And it also doesn't consider that new technology can help expand our food supply. So the food supply doesn't necessarily have to be linear, it can be more geometric in form. And one term that is commonly used with this model is the neo-Malthusians. So these are people who support what he said and say that we need population control programs to ensure that future generations have enough supplies. So the next model is about the hoteling model. So this is also known as the locational interdependence model, and this is talking about how businesses need to know where other businesses are in order to place their own business. So this number 3 is the best way for consumers to get what they want because they only have to walk a maximum of, let's say this is a mile long, they only have to walk a maximum of a quarter of a mile. But this is best for the businesses because if one moves, then the other will move, and it'll just cause this great chaos. But this is kind of like a stalemate for them so that they can get the largest market that they can. But what this doesn't consider is that there are different terrains. So let's say there's a rock in the middle. So that means that Model 3 would be better than rather Model 4. And this also assumes that businesses want to maximize their profit, which is most likely the case, but let's say nonprofit places, they don't really want to maximize it. They want to donate what they can. So the next model is the concentric zone model, otherwise known as the Burgess, because Burgess developed it. So this talks about, this is one of the first models to show what a city might look like. So this talks about a CBD, and a CBD is a central business district. So this shows, this is basically a high concentration of businesses and commerce. So you'll see in the center, there's really tall buildings. So this means that it's usually the center of all economic activities within the city. So this is usually in the center according to this model. So it assumes that it's in the middle again. And the other sectors are based on the CBD. So the closer you are to it, the higher your land value will be because this center place is the very, very most important part of the city. And the further away, the more you have these commuter zones. So these people are most likely high income because they can afford to commute long distances to the center. So the closer areas will have low income neighborhoods. So what this doesn't consider is that cities might not even have CBDs. So countries in Southeast Asia, they don't necessarily even have a CBD. So the next model is the multiple nuclei model. So this was meant to critique the former model, and this was developed by Harris and Ullman, so that's why it's also known as the Harris-Ullman model. So this was shown to have that the cities have not only one CBD, but they have multiple. So you'll see here, you have one type, another type, and a third type. But these all attract different neighborhoods. So this was actually based in Chicago, which means that it probably doesn't apply to as many eastern cities as you might think. So this is also, this assumes that cities have multiple smaller CBDs, as you'll see in this model. And it also shows that there are equal opportunities to the resources. So there's not necessarily any discrimination within the city that shows that transportation might be different in other places, that population is not the same overall. And this basically shows that the closer you are to these cities, the more it costs. Again, from the last model, you'll see that there are higher land values as you get closer to these central parts. And you'll see here, there's this area where you have really high land values because you have these very important businesses that contribute a lot to the city. So the next model is the laws of migration. So this talks about what is most likely to happen when people migrate. So the most common thing is that people move short distances. So you're more likely to move, let's say, from Lawrenceville to Norcross rather than Lawrenceville to Athens. And that big cities attract long-distance migrants. So you're more likely to move, let's say, to London rather than the countryside of France. And the next is you're more likely to move from rural to urban. So you're more likely to move from metro Atlanta to the inner city. And another thing is that migrant flows produce a counterflow. So let's say you have Canadian migrants moving to the US, you also have US migrants moving to Canada. And most migrants are adults, and this is because they probably have less ties rather than families who have ties to other families and businesses, and just socially it doesn't make sense for them to move very far distances. And this is also because young males, they have less ties in places and they're more likely to make new ones, and it's easier for them to make new ones. So one of these criticisms is that this was written before the advancement in transportation. So you have so this was before trains and cars, and so the longer distances it's harder to move rather than shorter distances. And today more and more people are moving away from the city because they don't really like the city environment because it's very harsh for them, or maybe some other factors. And more women are migrating because less women are having children. And step migration is basically when migration occurs in steps. Well, obviously, and because these small movement it moves towards an end result. So you're more likely to move from, let's say, Buford to Lawrenceville to Norcross to let's say Atlanta, rather than moving straight from Buford to Atlanta. So the next model is the von Thunen model. So this talks about agriculture, and this talks about the layout of those agricultural activities. So on this side, you'll see a concentric version, and on this side, you'll see like a modified condition because of a natural border of some sort. So this is a river that's affecting it. So in the center, you have the activities that are most likely to rot the quickest, but they also yield the greatest incomes. So you have the market gardening and milk production. So milk is most likely to rot. But this was before technology came in and we had refrigeration, so that milk production could be further away. So this basically talked about the cost of transportation, and that the ones closer had the highest cost of transportation, so that's why they were moved to the closest. And the ones further out, so let's say livestock, had the lowest cost of transportation because, let's say, cows and sheep, they can move on their own. They don't need some kind of they don't need some kind of wagon like strawberries do. And what this doesn't consider is soil fertility. So because differences in soil fertility, that can move around what crops get grown where, and differences in climate and geography, those could all impact that. And it assumes that the closer you are to a city, the more it costs. So this is also, again, related to the distance decay model. So the next model is about the Heartland theory, which is also known as Mackinder's, because he developed that theory. So this talks about how whoever owned Eurasia, or whoever ruled it, sorry, could rule the whole world. Now, this was during the era of European imperialism. So this is when European countries were imperializing Africa and America and all of these islands. And so this was before Russia kind of had a downfall because of the revolution and then communism and just everything that deteriorated their empire. And so this said that anybody who rules East Europe commands the heartland, which is Eurasia. As you can see, and the world island is this whole landmass right here. And whoever controlled that can control the world. Well, the related model, the Rimland theory, contradicted this theory. So this theory was whoever controlled the coast rather than Eurasia control the world. Now, this assumed that Heartland doesn't have control in the first place, but it doesn't consider the amount of diversity along this coast. So you'll say Spain is very, very different from China, and there are many conflicts. So you have conflicts like India and Pakistan. So those wouldn't, and this theory basically considered the coastline as a unit rather than many different countries, and the diversity could create conflicts like in India and Pakistan. So that's it. Thank you for watching. I'll see you later.